Can you hear me? Let's let some people get in here. I did invite George, but he has he said he had a conflicting meeting, so he might not make it. But everyone that's here, welcome. William, no, I don't do boosting for HHO boosting for cars anymore. I quit doing that about 5 years ago. Well, the truth is gas prices went way down, so it forced a bunch of us out of business. So I concentrated on some other areas. Looks like there's about a 7-second delay between the camera and your comments before I can see them. So it'll take me a bit to respond to them. Hi, George. Okay, so it's 9:35, so I'm going to get going. So a lot of people have been asking for an attachment for their Brown's gas machines to make deuterium depleted water. And I've come up with something that I just want to share with the community instead of trying to market it or sell it. What I will do is I'll put a list of materials in the bottom of this video so that you guys can go pick up all the parts and assemble these yourself at home. Not hard to do, but it did take a while to figure out how to do it with these machines, and yeah, I'm going to share that with you today. But first, I want to show you the concept of how it actually happens and how we can collect the deuterium depleted water. So I've got here, I've got my Brown's gas machine here, and then connected to it is a torch. And the way that the water is created is inside the machine. The electricity separates the water into hydrogen and oxygen. That's where we get our gas. And then it's pumped through the output port into this torch. And when you light it, it'll obviously burn. And it's obviously flammable. But something really cool happens when the flame comes in contact with metal or any material. You can actually see how the hydrogen and oxygen recombine back into water. And when it recombines back into water, this is when it's at its. The first time I lit a torch, I was really amazed at the properties that the flame has. But one thing I did notice is that when you put it up against something, you could see that water was being created, and I thought that was really cool. But I didn't put two and two together until just last year. I didn't know anything about DDW until I started learning a little bit about it, and then I put two and two together that you could create it by this process. So I'm going to show you how the water, or how the hydrogen oxygen combine back together and form the water. I've got just a stainless steel plate here, and I'm going to run the flame over it and show you how you'll be able to see the water forming on the plate. So I'm going to go ahead and start up the machine, get it going. I'm not even really sure the stream is going anymore. It's just chugging over here. Oh, there we go. Looks like it's got a real large delay now. Okay, so we'll go ahead and light the flame. It's really hard to see. I don't even know if you'll even be able to see it there. It's a little tiny flame. Now this machine's making about 400 to 500 milliliters per minute. As you can see, it's not much of a flame. But I'm going to see if I can get this on camera for you. You can see now, as I kind of touch the flame to that plate, see that condensation there? That's water. You can see how the water's forming on the plate there. There. So what we want to do, that water there is pure and it's free of deuterium mostly. I'll explain later why it's not completely free. But what we want to do is we want to build a way to capture that water so that we can use the water. And that's what I'm going to show you how to do. Any questions so far? Okay, if I were to hold this torch to that plate long enough, it would melt right through. Okay, before we start building it, let's talk a little bit about safety. So this technique is going to work on any Brown's gas machine. So whatever you got, it's going to work on. But you're going to want to be safe. So this flame, the Brown's gas flame, has a perfect mixture of oxygen in it for it to burn. So if I were to light it here without this torch tip, it would burn up through here, all the way back through your hose, into your machine, and then when it hits an air pocket like here, this is going to explode. Okay? So what we do is we put a flash arrestor in line. So when you quench this flame, you'll always get a flashback. So when I turn this off, it'll flash back every time. Well, most of the time, not all the time. When the flame is larger, when you've got more gas volume, it'll definitely flash back. So you're going to get a flashback every time you turn it off. So we put a flash arrestor in line. That flash comes through the line and stops at the arrestor. And I always recommend to have two safety measures. So there's two flashback arrestors in the system. There's one inside. If you're going to do this, I'd run two of these in line just to be super safe. Because no one wants an explosion in their face. So, to put it bluntly. Okay. Yeah, there's other ways of making deuterium depleted water. This is one of the ways. There's a better way to do it that most of the companies that are producing it are doing it, but it costs a whole heck of a lot of money to set it up correctly. This way can be done by just about anyone. The testing I got from Simple Lab. Here's the one test I did. It was on a different setup, but it came back at 44 ppm, and I'll show you some ways that I think I can lower that number down. That was pretty raw when I first sent the sample out. But I was a little disappointed in that. I was hoping to get 25 or lower, but it's a good place to start. And another place I'm using. Let me get the kit. this is the one I'm going to use next time. And I don't remember the name of the place. Let's see, www.ddcenters.com. And it's just a little kit. Here you measure out a little water in a vial and send it back to them. Use a mass spectrometer to read how much deuterium's in the water. I don't know what to do about the freezing feed. I'm doing this on my cell phone. I don't have any of the fancy cameras and that kind of thing, but after this is done, it'll be automatically uploaded so you can rewatch it. I apologize. Okay, so what we're going to be building essentially looks like this. It's a crazy setup, but it works, and I'm going to show you how to do it. So I've got the parts here. All these things I got from Home Depot, and you can use stainless steel fittings if you want. So I've got a couple couplings, a coupling, an adapter, a T, and a couple nipples. Then I need some Teflon tape, and I've got a coil of 20 foot of copper, 1/4 inch. I try to use the stainless. It's a little bit harder to work with, but I suggest taking all these parts out and cleaning them thoroughly, because once you start building the water through, it's going to pick up anything that's on the inside, and you're going to get it into your water. And I also recommend, after making some DDW, to distill it, so you get any of the things out there, in the lines and the copper lines. Okay, so essentially what we're going to do is we're going to build a chamber that we can stick the torch tip into, and we're going to seal the top so the flame goes down inside, and all the condensates collect, and they run down the tube, and as the steam, there'll be steam there too, as the steam going through the tube, it'll condense on the walls of the tube and then form into water, and we'll collect it at the bottom with in some kind of container. Let me get all this stuff out of its packaging. Oh, and also the secret component that makes it work is this aquarium pump. I spent a bunch of time trying to keep the flame lit with all these different configurations stuff. Couldn't keep the flame lit until I added this to the system. I'll show you how to use that. I'm not an expert on frequencies, so I'm not really sure. I'm not really sure that a frequency can be imprinted on the gas, but it's possible. I don't know how someone would verify that. That was for Johnny. Okay, so what we're going to do is we're going to put these parts together. I want to wrap these with Teflon tape, just a little bit of tape to seal it up. Okay. Wrap these two ends. Alright. That's going to go in there. This in here. This one down here. And this over here. And that's going to complete the chamber. So this is where we're going to put our torch. This torch just happens to fit in here really nice. And we're going to put a little bit of Teflon tape around this so we get a seal. And we're going to build our coil and attach it to here, our condensing coil. We're going to want to take these and we're going to want to tighten these down. Okay. Yeah, okay, so you always want to bubble your water. That filters out some things, some impurities, and also to make the gas more pure, I guess, for making deuterium depleted water. You want to take out any moisture in the gas, because any moisture in the gas could have deuterium in it, and then it ends up in your water. So if you were to take and use a dryer and run your gas through a dryer, this would dry the gas, take out any moisture in the gas whatsoever, so you just have pure hydrogen and oxygen. This, I think, will lower the deuterium number greatly, but I haven't sent in a sample yet, which I'm going to be doing to see if that actually is true. And inside of here this is just a water filter housing. Inside of it is desiccant beads. You can get those on eBay or Amazon, and that completely dries out the gas. Okay, let's make our coil. Neat thing about these from Home Depot, it comes already pre-coiled, so if you don't want to coil it smaller, you can just leave the coil big like that. I'm going to make a smaller coil. I'll show you how to do that. So here I've got a 6-inch pipe. I'm going to coil this around the pipe so I can make myself a 6-inch coil. let's just start the coil around. If I'm lucky, I'll get this all straight. Thanks for answering that question there, Kay. I don't know if I mentioned, but this is a 20-foot coil. So you're going to need a pretty long coil because this thing heats up pretty good and it takes a bunch of coils to cool it down. But by the bottom of the coil, it's cold. Getting to the end here. I could have probably coiled this a little tighter, but I'm trying to save a little time here. There's our coil, and we're going to need another small coil. Let me cut this off. This is a tubing cutter. You get this at any home center in the plumbing department. It makes a nice perfect cut. Alright, so there's that coil. And we're going to make another smaller coil to put the air into from the aquarium pump. This is a 4-inch piece. You could just coil it any way you like. It's just to dissipate a little bit of heat before it gets to the plastic tube that comes with this pump. So it's got some rubber tubing in there that we'll use, but we don't want it melting. So doing a little coil here so it can dissipate some heat before it gets to that tube. Okay. Alright. This stand I got on Amazon. It's like a lab stand. I'll put a link in the description down there so you can get one. Now what we're going to do is we're going to attach our main coil to this fitting here, and then the smaller coil to this fitting here. I'll just put a bend in it there. You want everything to always travel downhill. So as your water is collecting or condensing in this line, if it goes uphill and then goes back down, you'll collect a bunch of water in the tube, and it'll take a long time for it to for you to get any water out the end. So you don't want it collecting in the tube. So do that. And then we're going to put this on here. This is the, I'm going to have to cut this in because it's a little bit mangled there. It's not going to, I'm not going to be able to put that on there unless I cut a little bit off. See the end of the tube there. If it's not completely round, the fitting won't fit on it. And it fits right on. Okay, we're going to tighten that a little bit. Once you tighten this, it won't come off. That ferrule will be locked onto the tube. There we go. And now we're going to attach this smaller one. Side here. one still there? Or did the string cut out? Okay. Alright, now we've got our chamber and our condensation tube, condensing tube. And this here is for our pumped in air. This here is to hold it all. There we go. I think I lost the feed. It looks like I'm still there, but no one's saying anything. Oh yeah, I guess.
You lost it.
Guess it's still going. Kay's still there. Okay. Alright, there we go. Alright, now we're going to hook our pump up. The reason why we need this pump is because with these Brown's gas machines that don't produce that much gas, under a liter per minute, the flame will go out. So what we do is we add a little bit of air to the system so that our flame won't get extinguished. Let's start up the Brown's gas machine, get it going. This one here has a dual output. I got it because you can adjust the flow on it. I wasn't sure how much air would be needed to keep the flame going, but this came in handy, being able to adjust the flow. You'll have to adjust it and to the point where your flame stays lit. So this here, we'll need a extra piece of tubing. Grab. So that's quarter, this is 5/16, so you need a piece of 5/16. Slip your tubing in. So it'll slip over the 1/4 inch here. Okay, last thing is you're going to install your torch. I'll put a link to in the description where to get these, and also these flashback arrestors. Make sure you have 2 flashback arrestors installed, and then just install your output line onto the torch. Now on the end here, in order to get it to seal up here on top, we're going to have to put some Teflon around this fitting here to look something like that. So just wrap Teflon around it. So look something like that. That's going to seal it. Now we're going to go ahead and light it. And then all you do is stick it in the top there. It'll fit in nicely and seal. And that's it. Now we're capturing that water that's condensed, recombining together. We're capturing it here in these tubes, and it's going to cool as it goes through the copper line, and then you're going to get deuterium depleted water out the bottom. If we didn't have the air going through, you wouldn't be able to sustain a flame. So we need to put some air through it to sustain the flame. Also, it's nice to have the air going through. If your flame goes out, all your lines will fill with Brown's gas. And then when you light your torch to put it back in, the tubes will be full of Brown's gas. You'll get a big pop. All the gas inside the lines will explode and you'll get a big pop. So this air going through it keeps the gas, actually pushes the gas out of the tubes, so that when you light it again and put it back in there, you won't get that pop. This now is going to start to heat up. It's going to get really hot. And you can feel that it's hot. It's getting warm down here. And then these are all still cool. Okay, so here's the kicker about this whole thing. So you can only make as much deuterium water as the water that's being split inside the generator. So if your machine can split an ounce of water in an hour, the most deuterium depleted water you can get is an ounce. If you have a high-powered machine that runs at 2, 3, 4, 5 liters per minute, it's going to be able to split more water faster. So you'll be able to produce more deuterium depleted water. So with this machine at about 450 to 500 milliliters per minute can produce 1 ounce of deuterium depleted water in about 2.5 hours. So it's not a very fast process. I was able to get this from this machine in about 2.5 hours. Now, this here, I sit in a large sample. The other company had me take a large sample, but I filled this all the way to about here. This I made with another machine that generates about 4 liters per minute. And it took me about 16 hours to get all this at 4 liters per minute. And then what I did is I ran it through a distiller. I have a home distiller to take out any impurities, and this is the water that I sent the sample in that came back at 44 ppm. So now it's going to take quite a bit of time before you get a drop out of here, but just put yourself a container or something to collect the water at the bottom. Okay, ready to take some questions. I'm not sure I understand your question, Hans. No, you don't have to run the gas through a bubbler. If you're going to distill the water afterwards, I don't think it's going to matter. If you don't have a bubbler, that's fine, but the bubbler takes out, any lye that might escape. If you don't take out the lye, it's going to end up in the gas, and you may see it in the deuterium depleted water. So I think it's a good idea to bubble the water first. Now we're real hot here now. So now it's warm down to about here. And then super cool down here. Either the stream's lagging or there aren't any questions. I'll leave the stream open for a few more minutes if anyone else has any questions. I haven't done that calculation yet, but at the rate, the amount of money they charge for this water, in my larger setup over here, I could have easily saved a bunch of money making my own. Let me show you the other machine. Move this camera over here. So this here it's a little bit of a mess right here, but this is the other machine. Just to give you an idea how big it is, there's my hand. I've got a big hand too. So it's 59 plates. The plates are 8 inches across. it'll make 5 liters a minute easily. Water tank there, and then I'm bubbling it through this large bubbler here. Safety first, there's a flash port up there. And then it goes down into a series of dryers. I've got 3 in here now. And then through, this is a Flashback Arrestor also. And then here's the torch I'm using for this one. It's larger. And then the chamber I used is right there. And it's got the coil down here. Anyway, I just set that up to make enough water to send back for a test. But yeah, this machine, it has the variable output here, so you can control it. That's the AC to DC converter, because these generators run on DC, and that just plugs right into the wall. And then over here I've got my home distiller. So I distill the water before I send in for a test. So this machine here will make the water a lot faster, and it uses quite a bit of electricity, but the amount of water you get out will be a lot cheaper than buying it. And before, when I got the 44 ppm, I didn't have these dryers here. So I'm pretty sure if I dry the gas completely, I can lower that number. Hans, no, the air pump keeps the flame from being extinguished. It keeps the flame lit. Without the air pump, if you're running a machine under 1 liter per minute, the flame's going to go out. So you need to pump a little bit of air in there to keep the flame going. So that's what the pump's for. Yeah, it's not for cooling the air, it's just to keep the flame lit. It's also to keep the lines free of any Brown's gas. In case the flame goes out, it clears all the lines of Brown's gas, so that when you put your flame back in, it doesn't ignite all the Brown's gas in the tubing. Well, I want to thank everyone for stopping by. Appreciate you joining the live stream. And I will finish this video up. It'll be up on my channel, Delvis11. And I'll have all the links in the description to where you can buy all the parts to make one of these at home. If you have any more questions, just leave a comment in the comment section here. And I'll be glad to answer any questions that you have. Also, you can email me at info@hydrogen4health.com. Be glad to help anyone out. Alright guys, thanks for watching.